My name is Paul LaBerge. I'm a technical evangelist with Microsoft Canada. Those of you that know Fred is my colleague. So he's the Montreal crew. I am the Toronto crew. What's that? No. And there's my contact info if you're looking for it, both on Twitter and on email. Happy to have a conversation with you if you want. So we're going to talk a little bit about game development using HTML5 mainly, because that seems to be a lot of the ways that you're seeing social gaming start to become prevalent within the developer community for a number of different reasons. So what I'm going to do is I'm going to go through, well, might as well just go to the agenda, and we're just going to go to an HTML primer, so talking about, HTML5, what it is, and things like that. We're going to talk about Yetis, which, as you can see right here, the Yeti is the abominable snowman, also thought to be believed to be a member of the Bigfoot family, I guess you could say. So it's actually pretty funny. When I was doing this prep for this presentation, I went to Wikipedia. Apparently, the main picture for the Wikipedia entry is actually not a picture like this. It's actually a picture of this weird scalp that the Nepalese monks thought is a scalp of a Yeti, of all things. So it's kind of weird. But anyways, we're going to talk about that, and then we're going to talk about game structure, because I think those are the things that are probably going to become very, very important for you when you actually start building games. All right. So the first thing we're going to do is do an HTML5 primer. But before that, this is probably the best known Yeti. It's also known as the Bumble. Anybody here know who this is? Anybody recognize? Yeah? I look forward to this every December. It's the Rudolph the Red-Nosed Reindeer, the original. Yeah, the original. This guy is awesome. And I got something at the end of the presentation that may surprise you and you might find kind of funny. So anyways, that's just a little bit of trivia there on the Bumble, which is the best known abominable snowman. So the first thing we're going to do is talk about the document object model in context of gaming. So there's a number of different things that you have, and one of the things that you may notice is we have this game called the Yeti Ball. I can give you the code to Yeti Ball. I'm not really going to go through it in great detail because it's probably a little bit more than I have in time for an hour to actually make this happen. But you can make use of this in games going forward, so you can use it as a template of sorts if you want to actually build out your own games. It's kind of like a Donkey Kong type of idea, right? So if you take a look at the, from a gaming context, the document object model structure, we have a container. And the container is basically your web page. And the game canvas itself is basically where you actually put the game and where all the magic happens. In fact, that's not entirely true either, because the canvas really is kind of a static thing in a lot of ways. The real magic happens in the JavaScript, and I'll explain a little bit about that when I show you some demos about how to do some interesting things with Canvas down the road. From an example standpoint, this is a bit of a code example, right? So you have basically a container that might be a div, could be just a plain web page or whatever, and then inside that you have a canvas. And the canvas, you basically define what the width, the height, and all those types of things are. And then you might have something that might sit on top of the canvas, such as a div where you actually have a button to actually throw the next snowball down or whatever it is that you want to do. So that's just a very, very quick example of some of the stuff that we do. But let's talk a little bit more about the canvas element. The canvas element is really something that's fairly new within HTML5. And it's one of the things that I think is one of the most powerful additions to what we call the HTML5 specifications overall. Because in this canvas, you can do an awful lot of different things that allow you to build some really dynamic things that you typically couldn't have to do within HTML, or it was very, very difficult to do that. A lot of the things that you see today that are considered quote-unquote HTML5 experiences on the web are basically were not possible in HTML prior to that. You had to go to Flash or Silverlight if you were using the Microsoft side of things, those types of things. So really the game canvas is really the most important thing for game developers using HTML5 today. Now, more trivia. This is the Wampa. The Wampa is the Star Wars Yeti. It was provided in or shown in Empire Strikes Back. It's the thing that decided to try and eat Luke Skywalker, much to his own chagrin later on. So, next. All right, drawing images to canvas. This is fairly easy to do. So one of the things that I said before was the fact that canvas is a static sort of element, right? There's not an awful lot that the canvas can do other than define the height and the width and all those types of things. So what you can do within JavaScript is add functionality or add richness to the canvas to allow you to do some interesting things. So if you're actually putting on a snowball, as it were, you would actually define within your JavaScript an image, create a new image type, define the source of that image, and then basically associate that image to drawing the image to the canvas and something like that. Nothing too wild there. Some other examples of that you can find basically right here. So you can actually get the canvas element, so get the canvas from the actual DOM within your JavaScript, and then basically you set the context. Now, this is really important because, and I'll show you some examples of this when I show you some demos. Context is actually one of those things that defines how your canvas is actually going to react and behave when you're actually making use of it. So there's two different types of context, at least that I know of, two-dimensional or 2D and 3D. So 2D is pretty much the typical thing that you see on HTML5 canvases today. So if you're building a game that's similar to Angry Birds, that doesn't require an awful lot of things like light sources or 3D engine like creation and things like that, you'd probably use two-dimensional canvas context because that makes things a lot easier. If you're trying to build Halo, you'd probably want to do that in three-dimensional because you have to deal with light sources and gradient shades and all those types of things that typically change depending on the context of where the user is and things like that as well. So that's just an example. So let's see how you can actually draw the canvas, draw the image to the canvas, or the snowball in this case. So what you have is, say for example, you have a 256 pixel by 261 pixel sort of source image. What you can do is you can use the draw image function, or that you see right there, the method, where you basically define the image. So in this case would be snowball.png or whatever it is that you want. Set where you're actually setting the position, so 0, 0 being the X and Y elements, and then the source size, so you can actually dynamically change the size of the image depending on what you want, and then also the destination. So you can actually set a whole bunch of different things within there if you want. So that's just really a very quick overview of the types of things that you can do with Canvas from a PowerPoint standpoint. But I'm actually going to show you some magic within Visual Studio that allows you to sort of get a better feel for what Canvas really is. And not all of it is going to be necessarily in the context of a game, but just in general. But I think you'll appreciate why I'm saying this. So I have here Visual Studio. We okay with the dark, or should I put the light theme? Does anybody prefer dark theme over light theme? Who says light theme? Who says dark? Okay, so I'll put it to light theme. It's just easier. When I do my development, I prefer the dark theme. So, all right, change that. I did that just to make you walk around. So the first thing I'm going to do is I'm going to show you the very easiest example of Canvas, which is right here. So I'll just make this a little smaller, just make this over here. So Canvas, right here, so I have the Canvas tag, and inside that tag I have Canvas is not supported. So this is something you should probably think about if you're doing web development and things like that, because if your browser does not support HTML5 tags, it's not going to recognize the Canvas tag that you have in there, and it's just going to walk right over it, in which case it's just going to type out that text that says Canvas is not supported. You can put whatever you want. But as you can see, the Canvas tag itself does not have an awful lot of functionality to it. That's all it is. Well, let's take a look at what this thing actually does. So if I right-click on this and open it with Internet Explorer, that's interesting. Okay, well, let's take a look at that. I right-click on it. It's not an image. It's actually the canvas itself. So the real magic, as I said before, is that there's no actual anything within the canvas that actually makes this work. It's actually something within the JavaScript. So let's take a look at the code. So basically what I've done is I've added an event listener. And an event listener is basically something that triggers when you're trying to do something. So in this case, what I'm doing is, as you can see, there's a load parameter in there. And basically what I'm saying is, when the page loads, I actually want to trigger this code. So this is basically an event handler or a listener in the case of JavaScript. So what I'm doing is I'm defining a variable called canvas, and I'm getting from the document object model the canvas, right? So in this case, that's just this thing right here, okay? So basically now I have the canvas loaded within memory in a variable. And basically what I'm saying is if the canvas, or if there is no canvas, or I can't get the context of a canvas, then basically don't do anything. So that's basically sort of error detection code to make sure that, if something really went wrong, you don't want to continue going forward. But if I can, basically what I'm going to do is I'm going to say, okay, well, the context in this case is going to be two-dimensional. I don't need all the fancy stuff that three-dimensional provides. And then what I'm going to do is I'm going to create a variable called gradient, and I'm going to actually create a linear gradient in JavaScript right here. So this is just something within the context library that allows you to do this. And then I'm adding color stops. So I'm saying going from white to blue, and then I'm basically saying the fill style for a context for the context of the canvas is type gradient, and then fill it with a rectangle. So basically that's it. So this is not an image. This is dynamically creating via JavaScript a gradient. Now gradients themselves are very, very useful in the context of building out games and things, because that's something that's quite interesting in things. So that's something right there. But let's take a little bit closer look at things like drawing. So dynamic things are obviously important within games. So I'm going to show you this before I actually show you the code specifically. So what we have here is I have a save button, which is just your typical save or your typical input button from HTML. I got a broken image here, and I'm going to figure out what that is in a second. But right here, what you can see is a canvas, but as soon as I go on it, so I can make drawings, right? So I'm actually providing input into the canvas, and I'm doing all this fancy stuff. And then I click save, and it's actually pushing it there. So let's take a look at this. If I right-click on this, well, that's interesting. Data image of type PNG, base 64, and then all the data associated with it. Okay? So that in itself is not necessarily particularly interesting. By the way, this is a rendition of what Fred would look like with hair. Yeah, you didn't even hear me. There you go. So, all right. So, let's take a look at this. Again, the canvas in the actual HTML markup, nothing special right there. It's just canvas tag, and I've said it's 400 by 300 in height and size, or width and height, I should say. Then I create a standard input button, value save, and then I have a method that I'm basically hitting when you click the save button. Then I have an image, and the image is basically not defined. I don't give it a source, right? So what I'm going to do is obviously when I hit that save button, I want to take what I put on the canvas, and I want to save that into an image type, and then put that right beside it into that image tag. So let's see how that code actually looks. So what I'm doing first, I'll get to the save in a second, but I'm going to go to the onload listener. So again, when the page loads, I'm getting the canvas into a variable and setting the context to two-dimensional, the same stuff that I've seen before. Then I just got this started variable as false, just to say whether or not I've actually started drawing something. And basically I'm adding an event listener within this, saying every time the mouse moves on the canvas, I'm going to do this function. And this function basically is, okay, I got an X and Y, which as you can imagine is where I'm going to set the X and Y coordinates within the canvas. And basically what I'm doing here is I'm saying, just saying in the layers as well, I'm not going to really get into that. But this is where it's actually kind of interesting. So what I'm saying is, if I'm not started, so if I haven't actually drawn anything yet, begin a path. And a path is basically something that is, for lack of a better term, I'm probably using the wrong term, a vector of sorts. So basically I'm saying I have a start and an end. And between that is a vector between that. Right? So basically what I'm saying is that the context, begin a path, move to the new path, and then say the start of this true. Otherwise, if it is started, create a line from X to the new coordinate. So from one coordinate to the next coordinate, right? And then that line doesn't actually show up until I say create a stroke. So basically what I'm doing is every time that the mouse moves, I'm actually capturing that event that fires. JavaScript is going to grab that event, find out, okay, well, I knew where it was before. Where is it now? Create a line, and then actually draw the line on the canvas. So that's why I was able to draw all that kind of stuff right there. And that's basically it. Now let's take a look at the Save button. The Save button, again, when I click the Save button, I'm actually getting the canvas variable, right, from the document object model. And it's very, very simple. I'm saying the image that is defined in the div, or not the div, but the image that you see right here, so ID of image. So I'm getting it as well from the document object model, right? Get element by ID. And the source of it is canvas.toDataURL. So all this data that's associated in the canvas is stored. And basically what I'm able to do is transfer that data, which is just a binary stream of information, push that to an image type so that I actually create that image. So I've actually created an image on the fly on client-side JavaScript, which is kind of cool. Okay. All right. Next thing, images. Talked a little bit about the fact that you can draw an image on the canvas. So I'm going to show you a little bit how this is implemented. Again, the magic here is not in the canvas tag. That's just strictly a container for you to actually do whatever you want to do.
Paul, a question.
Yes.
In the previous example that you had there, when you create that data of the image, can you save that data and use it as your source later on?
Can I save it? Like, what do you mean by, like if I right click on that and do save as within the browser?
If you save it into a file, if you save it into...
You can make use of that if, yes, I mean, within the limitations of JavaScript, you can try to save that locally if you want. Chances are it's probably easier if you have the user do the interjection if you want to do that. So like have a save button or just have the user just right click on it and say save as, right? It's just an image at that point, so it's whatever you want to do with that. Okay. All right, so let's take a look at the actual code. Now what we have here is an event listener, right? So on load, I'm going to create I'm going to show you what this looks like in a second. Create a variable that I'm going to call fish, and I'm defining it as a type image. So basically I'm creating an event listener for the fish on load of the actual document, create a context, getting the canvas, and getting the context of the canvas as well. So this is a way to make it a little bit smaller. So you don't have to do 2 lines of code to do the same thing. You can do all things in one fell swoop if you want. And then basically, kind of what you saw on the slide that I had before, context.drawImage, the fish, and then where I actually want to position it and finish it. And then I say the source of the fish variable is basically images of type fish right there, fish.png I should say. So if we take a look at this, as you can probably imagine, there you go, there's a fish. By the way, anybody know what this fish is? You can't answer, Fred, because you probably already know. If you don't, well then, don't admit it. What is it? Sorry? A piranha? No, not a piranha. It is a beta fish. Now here's some trivia for you. You may have seen this image of a fish before. In fact, you may have seen the quote-unquote modern UI style of this fish, which used to be called Metro, on the early versions of Windows 8 before we'd launched it, as well as this one specifically was in Windows 7 before we launched. So basically, it's a little bit of a trivia thing for anybody that wants to know. The beta fish was the wallpaper that we put on our beta versions of our Windows products for Windows 7 and then for Windows 8. So, anyways. There is no alpha fish, at least that I know of. Maybe the product team has one. Fred, do you know if there was an alpha fish? No? Yeah, well, that's it, like the modern UI version. Maybe if I have time, I'll show you the modern UI version of the beta fish.
That was in the dev preview.
Yeah, the dev preview. You got it. All right, timers. Now, this is interesting. I'm just going to actually show you in Internet Explorer first because I think this will set the stage for a number of different things. So I have 2 different timers going on at once. So on the left-hand side, we have frame-based animation. And on the right-hand side, we have time-based animation. This is all being done in the canvas and driven by JavaScript. Now, I'm going to show you the code in a second. But the reason why this is important, especially in the context of games, is because you have to make decisions based on the performance that you expect your PCs will actually have, the user's PCs. So frame-based animation is great because it makes use of as much power of your actual PC as possible. So basically what's happening right here is that the canvas, the code that drives the fish going down on the frame-based side, is saying every time that I can redraw the canvas to actually create a new fish, do it, right? So depending on how powerful your PC is, you can actually draw more frames per second, right? So if you're familiar with, well, okay, so who here has seen The Hobbit? Oh, yeah. How do I sync it with this? Basically, you repaint the canvas. Yeah, that's generally how games work. So there is an interesting thing about games, and we'll get into it a little bit later, but basically the whole idea is when you take a look at game mechanics, you have a draw and a game loop. So basically the game loop is basically it loops back over and over and over again, and then you have a draw method, right? So that's literally the game mechanics. There's a whole lot behind that as well. But if you're talking about the simple stuff about a game, you're saying, I want to draw something on the screen, do something in the background, then redraw it. So that's the game loop right there. Okay. So who here has seen The Hobbit? Who here saw the 3D version? Okay. Did you notice that it kind of looked more like a home video camera as far as like the, how vivid it was and things like that? Well, that's because they were using very, very high frames per second in the actual camera itself. So typical, I'm probably wrong in this, but typical movies are at around 40 frames per second. 24 frames. 24, thank you. Yeah. And I believe this was at 60 frames per second was the new Hobbit movie or something like that they decided with in 3D. So that's why it kind of looked different, is because they were able to actually provide more information per second. So more frames per second than otherwise. So that's similar to what you have here with the game. So in this case, you can see here, I have the beta fish on the left is going much faster than the time-based one because my computer is fast enough that it can draw more frames per second than I have defined as a time-based. And time-based is basically saying every X number of milliseconds, for example, redraw the canvas, right? So you have to make a decision one way or the other whether or not you really want to do frame-based drawing or time-based drawing. Both have advantages and disadvantages. So let's take a look at the code. So again, canvas, nothing special, it's just a single canvas. And basically what we have here is on load, add an event listener, get the context, all that kind of stuff, create an image, right? And basically set the interval of the draw to 16, which is just, you'll see that in a second, and set the source. Now, as far as the draw is concerned, basically what I'm doing here is draw. This function will draw both the frame-based version and the time-based version. So let's take a look at the frame-based drawing version right here. So what I'm doing is that I'm getting the coordinates of the previous place where the fish was actually drawn last, and then basically saying, based on, okay, what's the distance that it was actually the next thing. So basically what I have here is I'm saying, if the distance down is more than 400 pixels, refresh it and go right to the back of the top. That's why it always keeps on seeing like it's recycling back and forth and things like that. So basically what I'm doing here is every single time I can draw a frame, I'm clearing the rectangle, filling it with the title right here, right? And then drawing the image of the fish. That's basically it. So that's going as fast as I possibly can. Now time-based animation is a little bit different. So as you can see here, what I've decided to do is get the time, right? So saying now is the current time. And then the delta between the time from now is basically the time from now from the time of the last frame that I drew divided by 1,000, so per milliseconds. And if, for example, and here's just the speed, so I'm saying basically the second version of the fish is basically speed times the delta. And basically what I'm doing is I'm redrawing based on milliseconds instead, is all. Okay? All right, next one, transform. Now I'll show you this one.
Question.
Sure thing.
How do you make that loop go? In the previous example, I didn't get that. How? What is the timer there?
What is a timer? What do you mean?
When does it trigger to execute the function back again?
So basically it was every 16th of a second. It's basically how I set it up. There was that 16 in the draw function. That's where I would, yeah.
Okay.
Yeah. So let me show you this next example quickly. So what I have here is a canvas that I've drawn a rectangle and I've actually transformed it across. So the very first one is actually this one right here that's like this, and then I'm basically doing an algebraic transformation. So one of the other things that's really important in game design and game development is you kind of have to know a little bit about algebra, because you kind of have to do things that might be transformations of images or assets on the screen, right? Because depending on how things work, this might be something that you need. So this is an example of how you can do this within canvases. Now this is not an image, again, show you just that there's no magic. It's just a standard canvas. And if you take a look at the actual JavaScript, very simple JavaScript. So on load, get the context and all that kind of stuff, and then basically do a translation. So basically what I'm doing is creating an iterative loop and saying that what I want to do is I want to rotate the context 0.2 times 3.14, right, in this case, every single time that I have to make a loop. So that's why the first one was at sort of an angle, not like this or not like this. Is basically this is the default, but basically I start on the angle because I've set it up for that. And basically what I'm doing is I'm saying fill the context with this specific color, and well, this specific color here, which is sort of a bit of a blue, as you can imagine. And this fourth one is basically the transparency. So if you remember, you could actually see a bit of a transparency, and it is showed through within this near the center. And basically fill the rectangle. So what I'm doing there is I'm saying draw the rectangle with the transparency, and then shift it over, transformation, 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 until I'm at the end of it. All right. Video. Video is interesting. Now I'm going to show this to you very quickly instead before I show you the code. So keep what you saw here, the gradient right here, and then you have basically the video going. So what I've done is I've actually created this interesting sort of shimmer or reflection type of idea. This is basically just HTML5 video right here, okay? I'll show you the tag for that, and that's another thing that you can do within HTML5. And here is a canvas that I've actually done something where I've actually done a reflection. Now let's take a look at this code. So if you take a look, I have the video right here. So I've just defined it as in a video tag, which is part of HTML5. So no longer do you have to do anything really unnatural as far as like ActiveX objects or defining an object, a Flash object, whatever it is that you want. You can certainly do that if you want, but you don't have to. So basically, if you have the ability to create video and serve it from some sort of service, you can actually make use of that. Then I got a standard break, and then I have the canvas underneath it. So the canvas, if you remember, was showing the reflection of the video. Now I'm going to show you how I made that happen. Bless you. So on load, I'm getting the video from the DOM, getting the canvas, setting the context. Pretty simple. At this point, I'm setting the width of the video equal to the canvas width, which will be 300. And then I'm going to set the height of the canvas equal to the video height, which will be 200. Then what I do is I do a translation. So basically what I'm saying is that the translation for the context is 200 pixels wide. And then what I'm doing is I'm actually going to do a scale flip. So basically what this is, if you're familiar with algebra, the 1 minus 1 is the equivalent of an identity matrix, kind of, except with a minus 1. So basically what you're doing is you're doing an algebraic transformation to flip it upside down. Kind of cool, right? So anything that I put on that canvas will actually be shown upside down, whether that's me putting an image there, whether it's me drawing an image there, or whatever from input, whatever it is. Instead, we're actually going to capture each frame of the video that we can and actually put that on there. So what we do here is, first thing is I create a gradient variable and set a linear gradient for the canvas, which is what you saw when I first started the actual video. You saw it was a black at the very top of the canvas, and it faded it off to white. And then add color stops. So basically what I'm doing is I'm saying that it's the first color stop is basically completely opaque, and then the other one's completely transparent. And then I set the fill style for the context, in this case the canvas, to that gradient. And then basically what I do is I set an event listener, and I basically say every single time I can get a frame from the video, take a snapshot of that video frame, and then put that on the canvas. Now, every time it gets put on the canvas, it actually is flipped upside down because of the fact that I've created that transformation. Kind of cool, and it's not that hard to do. Literally 35 lines of JavaScript, or even less if you want to call it that. The last one is an actual game. Now, games, when you're talking about actually showing a complete game, I'm not going to show you everything, but I'll show you what it looks like first. And I will mention that this is probably the easiest game possible. Here, I'm going to make this a little bit smaller so you can sort of see the whole thing. So this is an alien invasion game, except it's the dumbest alien invasion ever because they never fire back. But as you can see, I can fire at them. So this is a game that's meant for me. You can add video and everything else like that. If I right-click on it, it's just a canvas. There's no images or anything else like that. Now, the cool thing is, I can show you the code a little bit later. Maybe at the end of this presentation, I'll actually show you the code. But this is just basically on load the canvas. I'm drawing the background, and then basically I have loops for each of the aliens that come by. So I have a variable or an interval that basically determines whether or not to add a new alien and things like that. So there's some randomness there, and then they fly across at various different speeds. So you can basically define that. All these things are just sprite images. So these are just images that I've actually added to the canvas and done all sorts of things like that. Same with my tank that I move forward, as well as the bullets that might show up. Now, as you can see, the bullets, as I move back and forth, you know, there's some physics there as well. So that's all done in JavaScript. Very simple to do. And of course, you could add audio if you wanted to as well. But basically, if you take a look at that, this entire game is all of 265 lines of code of JavaScript, which really isn't that much for the richness that you see right there. Minus comments, yeah, but comments I can consider part of code. Yeah. Please comment your code. It'll save you. Yeah, it'll save you a lot of grief down the road. Yeah, there you go. Like it. All right, so back at it. And this is not a real Yeti. It's obviously somebody in a fake suit. So, anyways. All right, let's talk a little bit of CSS, cascading style sheets. So this is interesting because one of the things that's really great about CSS is it allows you to do a number of different things with the viewport. The viewport being, you know, the area that you can actually see information on the screen. Anybody here heard of responsive web design? Okay, so you already all know kind of what this is all about, right? So the great thing is we use this, you know, to create mobile games. You can create a similar game on a tablet or a PC. We also use it on Windows 8. So if you're building an HTML5 app, native application on HTML5, you'll notice that we use media queries to actually resize the viewport depending on the screen resolution of the actual page, as well as determining viewport of landscape or portrait. So that's all provided there. Now the other thing that's really cool is that there's a game. Anybody here heard of Perry the Platypus? No? Okay, so if you have a kid, chances are you know, but if not, you'd think it's just the coolest thing. Perry the Platypus is awesome. So it's a Disney cartoon, and they came out with a game that they brought out. I think it's Agent P it's called. But basically, Perry the Platypus is a platypus that's actually a secret agent that saves the world in every episode. And they brought this game out to Windows 8, and they also brought it to Windows Phone. But it's in fact just a web page. That's all it is. So basically what they've done is they've done the sort of the phone gap solution for Windows 8 and for Windows Phone, whereby you have a native wrapper and they actually use a web page inside of it to actually to provide the content. Same exact code. They use media queries to actually create the great experience for Windows Phone, which is a smaller size than you would for a tablet. So that's something to keep in mind there. So this is an example of what you have right here. So, you know, you can have all sorts of different things around structure. I'm not really going to get into this because of the fact that I got a few demos that I'm actually going to show you instead, because it's a whole lot more fun. Okay, so let's talk about that. How much time do I have? Huh? 10 more minutes. 10 minutes.
You want less or more?
I need more, but that's okay. Unless everybody wants to go, that's fine. Okay, let's show you some CSS. Okay, so what I'm going to do is I'm going to show you what this looks like first. What we have here is basically an image that I created with the checkered boxes just to be able to show you that you can create some transparency. So this is basically just a div right here, and this is literally just text, so it's not an image itself right here. And I've also created a drop shadow. So this is all done within CSS. Now those of you that have worked with CSS in the past or worked with web in the past, some of this stuff was actually really, really difficult to do. So an example, I'm just going to show you what it kind of looks like. So again, just to show you, all we have is a simple div right here, okay? So the div is right there, and then basically what I'm doing is I'm saying the paragraph type, setting the color, setting the font size, all that kind of stuff, so that basically it tells me how big the actual font is going to be and everything else. And then what we have here is an opacity. So the opacity is a new CSS3 feature, which is part of the whole new set of standards for HTML5 that allows you to build opacity using CSS itself, which is kind of a big deal. Because if you're using CSS to drive different sort of transparencies and things like that, you can absolutely do that now. And then also you can set backgrounds. And in this case, what I'm doing is I'm basically saying that the background is this color right here. Likewise, in the div itself, I've actually defined a background image, which is not anything new and everything else. But what I've done is I'm saying that we have a border radius of 9 pixels, which is new. So you can actually define radii for your actual assets, images or otherwise, for your actual things within CSS. Likewise, box shadows. So you can define how big your box shadows are going to be, as well as the color if you want them to have a specific color type of thing. So that's all there. It's all built within there. Now the other thing that was there was media queries. And I'm going to show you this because it's easier to show you first, and then I'll show you exactly the code, or the CSS I should say, for it. So, okay. So typical thing when you're talking about media queries is you make the browser smaller. So here we go, la la la, make it smaller, boom, 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 right? So that's kind of cool. Let's show you how that's done. So basically what I've created is a div of type class, or that I've defined as class box. And basically here, I'll start at the very bottom, is I'm saying a media query. So if the viewport is a minimum of 700 pixels wide, show image5.jpg, which is that one, okay? If the viewport is between 600 pixels and 700 pixels, show image4. Right? And so on and so forth until you get to the base one, which is basically this one here, right? So type box, the default is that. Now, I'm going to mention something about media queries because I think it's really important to think about this, because when people think of media queries and they think of responsive web design, which media queries is probably one of the most prominent things that people think about, a lot of people think about what I just did, which is making the viewport smaller, right? Making a large web page and making the viewport smaller so that it looks great on phones. Well, there's so much more to responsive web design that I think you guys should think about, especially if you're building for Windows 8. The reason why is because A, media queries play an important part of native applications and games on Windows 8, and it's not about making the screen smaller, it's actually about making the screen bigger. Let's think about it. We are now in a world where digital devices are everywhere. We have PCs, and what we define as PCs at Microsoft include desktops, laptops, tablets. We have phones, which are smaller screen sizes. But guess what? What's the big new frontier that's probably going to start coming later this year that I think everybody's going to start talking about? Television. Television is bigger than PC, much bigger in some cases. Responsive web design will become very important to driving the right experience based on the television itself as well. So keep that in mind. I think that's an important component to think about. The last thing I want to show you is something called WOF, which is Web Open Font Foundation, or I always get this one. What's that? Format. Yes. I always have to ask Fred about that one. I seem to miss that one all the time. Now, one of the things that's really painful for a lot of people is that they're trying to drive this great experience for their website or their game or anything else like that, but they basically want to use a specific type of font to do that, and it's very difficult to do that because you can't assume that an esoteric font is installed on the user's PC. So instead, what you start doing is you start creating images, or you do some unnatural things to the code to actually make it work properly or whatever it is that you do. So the web open font format allows you to actually make use of the font that you originally intended to make use of in your application on the web and in your games, for example, as well. So basically what happens is it installs the font for use on that page, and the user doesn't have to install it on their machine or anything else like that. So I'm going to show you what this looks like, and then I'll show you the code, which you probably already saw the code while I was just blabbering on. Hello, WAF. So I'll make this a little bit larger so you can see. So this is not your standard font, but if you take a look, it is actually a font. It's not an image, right? So what I've done is I've actually created an example where if this was the experience that I wanted as my header for my game or something like that, I don't have to create an image for it. I can make use of this font within the game itself, which makes things lighter also when you're talking about transmission of data and everything else like that. So I'll show you what the code for that looks like. So basically I have a H1 header, hello WAF is basically what you saw, and then the type font face for the class. Let's take a look at the font face class. So basically what I've done is I'm saying the font will be this, 3-dumb regular, which is the name of the font type, Arial, sans serif, and everything else like that. Now the font face itself is right here. Font family, 3-dumb regular, source, local. I do not know what that's all about, but let's just leave that where it is. But you basically provide a URL to the actual font where it exists. So this could be on your own machine or maybe on another site. And then format of WAF. And then you basically say whether you want bold, italics, or whatever it is that you want. So right there, you can drive a great experience right there.
Oh.
Yep.
What's happening when you put your mouse over CSS code?
What?
There is a little pop-up.
What, this?
Yeah.
Okay, so this is, okay. If you use Visual Studio 2012, you see Fred's trying to pitch product here. So if you use Visual Studio 2012 Professional or above, not the free versions, you're able to do web development. Now, part of that is we have the HTML5, Visual Studio 2012 HTML5 Web Essentials add-on, which is free if you have this. Basically what this allows you to do is it adds a whole bunch of functionality to the IDE so that you can actually get your work done and be in an interesting way. As you can see here, this is showing that in this case, this font family sort of attribute works on those browsers. So right there it tells you, what the compatibility is so that you don't have to necessarily completely test everything if you don't want to. It also provides you with some great ways to do that. This is just one of a whole bunch of things that the Web Essentials actually provide you. So just a little bit of a font pitch or product pitch there. Okay.
I mean, they work. It's just the extension.
Yeah.
They insert the extension. I just want to.
Yeah, no, that's fair. Like, I'll be honest with you. You probably know more about this stuff than I do, but that's something to keep in mind. Yeah. Okay, so I've just been given the proverbial hook. Oh, I thought you were saying hurry up because you're taking too much time.
Repeat the question.
The question is, some of that stuff doesn't necessarily work very well in IE. Let's face it. We're not there yet. We're getting there. But IE 10 is a whole lot better than anything else Microsoft's ever come out with for a browser. All right. Game structure. Zombie Yeti. Very cool. Okay. So this is kind of what I talked about a little bit when I talked about the fish example. How a game works. Basically, it's a set of pictures. It's like a movie, right? You have a picture, then you have another picture, then you have another picture. It's like a comic, a comic cartoon that, like you flip. That's literally what a game is. When you're playing Halo, that's what a game is. That's why Halo, for example, requires such a heavy amount of horsepower to actually run it. It's not because it's got a lot of code behind it, although that is the truth. It needs it because you're running so many frames per second that does a whole lot of generation of images per second to actually make that happen. So literally, that's why the games on Xbox, on PlayStation 4, for example, or 3, I should say, all those types of things require heavy horsepower, and that's why those consoles are very high powered. Is because you need that power to actually render these images, 20, 30, 50 times a second, right? So that's basically it. So to your question around, game structure and things like that.
It wasn't about game structure specifically.
Well, okay, sorry, yeah, it was about.
The screen, I know, if you draw the screen not at the right time, it can don't show it really well.
Yeah.
It shows part of the image from the previous frame and part of the image of the next frame.
Well, that's why you redraw every time, right?
Yeah, but you have to redraw it when the screen changes before. When the screen changes the screen buffer.
Yeah.
Before it goes to the screen itself, when the video card's memory.
Yeah.
So.
How does that happen?
Yeah, how does it happen?
Within the video card memory? Yeah, I'll be honest with you, I don't get down to the hardware level very well myself, but we can have an offline conversation about that, I guess. Yeah. But basically, from a game structure standpoint, this is literally it. You have an initialize, which basically sets up all the assets that are required to run the game to start off with. This is when you load up the game. And then literally you have a game loop, as I said. You have an update, which basically provides the functionality of what your game does. So every single time a frame happens, obviously there's some sort of input and output that's associated with what you have as the gamer has done in the game. The update method or loop, part of the loop, will basically define how the game reacts to the moves that you've made. And then the draw functionality, or the draw method, is really about the game saying, okay, what you've done, based on what you've done and what I think the game will do to counteract what you've done, do the draw method. That is literally game mechanics, which is kind of interesting when you really think about it. Okay, I'm not going to have a whole lot of time to talk through a lot of this. Where am I in? How much time do I have? Minus 5 minutes?
I need to be out at 8.
We'd be in here for 8 o'clock, but who here wants to see some more coding from Paul? Like, I'm actually saying that because I don't want to.
Well, I can show you more HTML5 examples. I can also show you the Yeti Bowl game, although it's not running properly for some reason, but I can show you the code if you want to see that. It's really up to you. Anybody?
Yes.
Yes. All right, let me see if there's anything specifically that I am missing here that you should see. Because I got a whole bunch of more. Yeah, this is just. Yeah. Entities, performance. Okay, what I will do is I'm just going to go through some performance stuff before I show you the rest.
Performance.
Yeah. Okay. Just a few tips on performance because I think this is important. All right, there we go. This kind of stands to reason, but when you're actually doing stuff, like as you can imagine when you're dealing with things on the canvas, you could draw a whole bunch of things that you might want to draw, but only draw what you need. Like if something doesn't need to be redrawn, don't redraw it. Because any call to drawing, as you can imagine, is expensive because there's input and output associated with that. And also reusing objects from a memory standpoint. So if you have something in memory and you can use that over and over and over again, obviously that's really important too. Because if you instantiate more objects, you may run into memory leaks, which obviously will lower your frames per second and all those types of things, right? The only other thing that I do want to mention here is audio. Audio is a very important component of any game, but you also have to be very careful about using a lot of different sort of audio channels within your application or your game because of the fact that it takes time to load and it does take up memory. So just some things there to think about. I am going to show you Yeti Bowl example very, very quickly. Unfortunately, like I said, I tried it and it just doesn't seem to want to work, so I'm going to have to work on that. But let's see here, recent projects. All right. Yeah, back at where it was giving me issues. So basically, this is a Windows 8 game, and actually, hold on one second. I'm just going to. All right. So the one thing that I'm going to show you here very quickly is the fact that basically all these things are HTML assets. So basically you have a default, you have the game, hiker, and all that kind of stuff. So if you remember kind of what I showed you before about the mountain and everything else like that, all of this stuff is done in HTML. And if you take a look at the default, just going to show you very, very quickly. It's not that difficult of a page. The one thing that I do want to mention here is that there is a web version of this game as well, which I can provide to you after the fact if you're interested. I'll put my contact info over there at the end. But one of the things that we've done here is add something called WinJS. Now, I don't know if anybody's told you about WinJS before, but WinJS is basically our JavaScript library for Windows, as you might imagine. This is a native JavaScript library that is basically providing projection to the operating system level itself. So things for camera access, if you wanted that. Accelerometer access, all the things that are required to actually fully integrate with the operating system, the WinJS library will allow you to do that. So that's how you actually make use of JavaScript and HTML natively, is through the WinJS libraries, which are included by default when you actually create a new Windows 8 application. Like I said, it's probably a little bit detailed to actually get into a lot of this. I can certainly give you the code if you want to take a look at it, but there's all sorts of, you can make use of any of the code that you see here if you want to take a look at it. I'll provide it on the web as well. So, because I am like 15 minutes over already, I think, at this point. So, yeah. Okay, so the last thing I want to show you is a couple things. Okay, the developer movement, which is kind of tough to see some of that stuff there for whatever reason, but who here has not heard of the developer movement? Raise your hand if you have. Okay. This is something that Microsoft Canada is bringing out. If you publish applications or games for Windows Phone, for Windows 8, or you create services within Windows Azure, which is our cloud offering, you actually get points towards prizes. So this has been very popular to date. You can win everything from laptops to home theater systems to water bottles, depending on what you want as well. All those types of things are available to you if you want to build an application and publish it. The prizes are actually pretty good. And in fact, a lot of people have gotten phones and things like that, although phones aren't technically part of the prize giveaways this time around. But it is something to keep in mind. Developermovement.ca, if you publish your application, keep a look at that. I did want to get to this because this is kind of fun. Talked about the Bumble before. He's on our payroll, and I'll show you why. See if I can get the volume up a little bit here. We own them. So anyway, I thought that was just a funny way to end it. But I can certainly show you some other examples of HTML5. I can give you the code to the Yeti Bowl solution if you want to make use of that. Change some of the assets and modify it as you see fit. Happy to do that as well. I hope you have fun building for Windows 8. The fact that we've actually brought HTML5 and JavaScript and CSS as a native option for you to actually build applications, I think is a big deal for us. A lot of that was actually driven by the fact that we actually have a browser that is a whole lot better at web standards than it ever has been before. So, who here hated IE or still hates IE? Yeah, okay, fair enough. Yeah. Don't put up your hand again.
I didn't hear this still.
Yeah. Let's face it, IE did suck. There is...
Much better.
It's much... See, yeah, Matt... I am biased. I do love IE10. IE10 is much better. We've done a focused effort on driving the web standards vision within our browser as much as possible moving forward. Hopefully you see that when you're actually building and testing towards that. It only gets better as well, okay? So we're revving IE in a way that we've never done before. We've increased the performance of the JavaScript engine. Chakra is the code name for it. That is actually driving the performance engine behind Windows 8 applications using HTML5 as well. So the things that we've done in IE have actually been brought and internalized within Windows 8 for these Windows 8 HTML5 experiences and things like that. In fact, what I am going to show you, oh, that didn't show up. Okay, hold on. Who here has Windows 8 installed on their machines right now? Okay, a few of you.
Everybody here.
Yeah, I guess it would make sense. Okay, when you install Windows 8, you probably had a lot of applications that were installed by default. These are the main ones that I'm talking about are the Bing applications, Bing Finance, Bing itself, Bing Maps, Bing Sports, Bing Travel, blah, 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 Bing, right? Reason why I'm going to bring up the finance one. Well, that's because of the projector, not me. Let's see if I can actually fix that. That is actually an HTML5 application. So, no, that's not what I wanted. Let's hope it doesn't cack it. Come on, work. Yay! Okay. Let's get back at this. This is an HTML5 native application using WinJS to talk to the operating system and everything else like that. So it's beautiful, right? It has a visual appeal to it and everything. There's some interactivity here, which is nothing too special because most stock applications have that kind of stuff. I have my watch list. I can get all these types of things. It doesn't look like a traditional HTML5 application, right? It actually looks native and it feels native. And in fact, what I can even do is the charms, which are part of Windows 8 in general, which are available anywhere in Windows 8, are integrated within this application as well. So you see here, I can actually search and say company name or symbol. So we'll just see how Google's doing, right? Boom. There, right there, so I have that. And if I wanted to say, oh, it's right here, I'm pretty sure I'm allowed to share. I can actually share information. Hold on, let's try that again because the thing was still loading. I can share this with email with somebody, so I can share this article from the application right then and there if you wanted to. It's very easy to do that, and there you can see right there. So all these types of things, we're not just preaching it, we're actually living it. And in fact, the HTML5 model was the first one that was implemented for Windows 8. Not the C#, not the .NET one. It was actually the HTML5 one because we wanted to make sure that we built the right model for HTML5 and web developers because we see this as an opportunity for you guys to not only use the skills that you have today building websites and awesome web experiences, but also maybe take a look at Windows 8 as a way to use those standards-based skill sets to build some interesting applications for our platform as well. So with that, I will finish this presentation. I'll put my contact info up again in case you wanted to see it for whatever reason. There you go. So feel free to give me a shout. P. LaBerge is my my Twitter handle, paul.laberge at Microsoft.com. In fact, PelaBears at Microsoft.com also works as well. So thank you. Hopefully this was awesome, and happy to hear from you. Would love to see you build some awesome apps for us as well. So thanks.